Welcome back to your CompTIA IT Fundamentals training course. In this lesson, we'll discuss internal computer components. The motherboard connects other components of the computer together through built-in ports, sockets, and cables. Motherboards on a desktop come in different form factors, with ATX being the largest and most widely used. Micro ATX has fewer slots than the standard ATX, and Mini ITX only have one slot. Desktop motherboards have a port cluster, which can be seen on the back side of the tower. A port cluster has many different ports, which external devices can plug into. At least one expansion slot is included in desktop motherboards. Expansion slots are used to add cards, providing additional ports or replace low performance ports. A laptop motherboard provides the same function as a desktop motherboard but differs in appearance. Instead of having a port cluster, the ports are attached on the edge of the laptop. The BIOS is a chip on the motherboard which enables components on the motherboard and connected to the motherboard to function. The BIOS contains software which activates the essential parts of the computer when the computer is turned on. Functions of the BIOS include locating the operating system, setting processor and memory speeds, and setting ports for drives and external connections, among other responsibilities. BIOS settings can be configured by tapping a specified key during startup. The settings contained within BIOS are stored on a chip known as a CMOS chip. The CMOS chip is powered by a small battery on the motherboard. Random Access Memory, or RAM, is temporary storage used by programs. When a system is powered off, RAM is cleared. Any changed or new data that is desired to be kept must be saved to permanent storage, such as a hard drive. To find the amount of RAM installed on a system, you can go into BIOS or use the System Information app. The Central Processing Unit, CPU, is the brain of the computer. It is responsible for running the operating system and apps. Utilizing the connections built into the motherboard, the CPU communicates with storage, RAM, and I/O devices. The CPU has the biggest impact on overall performance of a computer. Advanced RISC machines, ARM, are processors used by mobile devices, tablets, and small computers such as Raspberry Pi. The ARM processors perform basic tasks in comparison to the 32-bit and 64-bit complex instruction set computer, CPUs. A 32-bit processor supports 16 and 32-bit operating systems. The laptop 32-bit processor is typically not interchangeable with desktop processors. They were designed to use less power and use different sockets and cooling devices. A workstation PC is part of the desktop PC family. Workstations are primarily used in a professional environment. Workstation processors can support one or more CPUs on a motherboard and are optimized for computer-aided design, or CAD, as opposed to gaming such as on a desktop processor. A server typically contains two or more processors on the motherboard. The processor is designed for high workload and have larger memory caches than workstation processors. 64-bit processors support both 32-bit and 64-bit operating systems. A 64-bit processor supports larger amounts of RAM and can work with much larger data at a time. The majority of 64-bit processors have two or more processor cores, with each acting as a separate processor. As with the 32-bit processor, the same characteristics apply in regard to laptops, workstations, and server 64-bit processors. A graphics processing unit, GPU, produces output to a monitor. Many processors made for desktop and laptop computers contain the GPU. Workstations, desktops, and laptops designed for gaming, 3D rendering, and CAD often have a separate card containing the GPU. When the GPU is built into the processor, the GPU uses the system memory. If the GPU is on its own card, the card has its own memory. There are two types of storage for storing the OS, apps, and data in desktops, laptops, and similar computers. A hard disk drive, or HDD, has one or multiple spinning metal or glass platters coated in magnetic material. Read and write heads move across the platters to read, write, or rewrite data. The HDD is connected to the motherboard by SATA connections. A solid-state drive, SSD, uses high-speed flash memory instead of magnetic media. The majority of desktop and laptop computers include a network interface card, or NIC, allowing for a wired network connection. Most laptops and some desktops also include a wireless network card for wirelessly connecting to a network. Wireless Ethernet is generally slower and less stable than a wired Ethernet connection. Wired Ethernet is preferred when a consistent speed and secure connection is needed. Wireless is preferred when the connection is needed where cabling is unable to be used and network connections for tablets and phones are needed. While wireless is generally slower than wired Ethernet, 802.AC Wi-Fi can exceed gigabit Ethernet. For desktops that lack a wireless card or Bluetooth capability, a USB adapter can be purchased to gain this functionality. If the NIC on a desktop stops functioning, a new NIC can be installed by disabling the onboard NIC in BIOS, installing the new NIC in an expansion slot, and downloading the required drivers. The components of a computer produce significant heat. Most power supplies have a built-in fan, and processors typically have both a fan and heat sink. Systems should also have additional fans to cool the other components. If a fan is built into the power supply and the fan fails, the entire power supply should be replaced. Even while powered off, high voltages are retained inside of the power supply, which can injure or kill. Heat sink and case fans can be replaced. Higher-end systems often use liquid cooling as opposed to fans. We have covered a lot in this lesson. It is always beneficial to review previous concepts. In our next lesson, we will look into common internet service types. I hope to see you there and would like to thank you for watching. We are heroes to